Hello everyone, welcome back to the Alchemist. I am Karthik Makwana and now we are going to start the name reaction series in which we are going to discuss about the name reaction in the simplest and easiest way. So in this lecture we are going to discuss about the aldol condensation reaction, right? Aldol condensation reaction. In this reaction, two aldehyde molecules or two ketone molecules or one aldehyde and one ketone molecules are going to condense and we will get the product beta hydroxy carbonyl compound and then it further dehydrated and after dehydration we will get the alpha beta unsaturated carbonyl compound, right? First of all, we will see the reaction. There is the aldehyde molecule, right? CHO and CH3, right? It is the aldehyde molecule, and 2 moles of aldehyde molecule are taken, and then it will be reacted with the base, and the 2 mole of the aldehyde molecules will be condensed, and we will get the beta hydroxy carbonyl compound that is CHO double bond O, and then here hydroxyl group OH and CH. Right. So it is the beta hydroxy carbonyl compound. Why it is beta hydroxy carbonyl compound? See, this is the alpha position and this is the beta position, and on the beta position there is hydroxyl group. So hydroxyl group is on the beta position, and here is the carbonyl carbon. So it will be named as beta hydroxy carbonyl compound, right? Beta hydroxy carbonyl, right? And then it will be dehydration. So after dehydration, H2O molecule will be removed and we will get the alpha beta unsaturated carbonyl like this. Here is the CH3 as it is. Here is the alpha position from the carbonyl carbon, and here it is a beta position, and the between alpha and beta position there is a double bond. So it will be named as the alpha beta unsaturated carbonyl compound, right? Alpha beta unsaturated carbonyl compound. From the aldol condensation reaction, we will get the alpha beta unsaturated carbonyl compound. So here is the overview of the aldol condensation reaction. Now we will see the mechanism. We will go for the mechanism and we will try to keep it simple. We are not going in the complicated reaction steps, right? So we will go for the mechanism. See, suppose we have the aldehyde molecule, right? CHO and here it is CH3, right? Now we will react it with the base NaOH, right? Base will be abstract the proton and base will be abstract the proton from the alpha position. What we are getting? We are getting the carb anion, right? Carb anion we will get CH2 minus. Here it is the minus charge. And now this minus charge will be delocalized and this pi bond will be break and the electrons of pi bond will go on the oxygen. So we will get the enolate. It is the most important intermediate enolate, right? See, here bond is opened, oxygen minus charge and there is a double bond and CH2. So it is the enolate. Now the second molecule of the aldehyde comes CH3, right? And now the minus charge of oxygen will comes back and form the pi bond, and now this pi bond will be break and attack on the carbonyl carbon, and this pi bond will be break and electrons of the pi bond will go on the oxygen and make it oxyanion, right? How is it? See, there is the hydrogen as it is. Here it is double bond O. Here CH2. There is a carbonyl carbon. Here bond is opened. Oxyanion CH3 and hydrogen. Right? Now what will happen? We will react it with the H2O. So H2O molecule we can draw like this. Right? Now this oxyanion minus charge will be protonated from the H2O molecule, water molecule, and OH minus will be removed, right? And OH minus will be removed and oxygen, this oxygen will be protonated. So we will get the H, C double bond O, here it is CH2 and here CH3, oxygen will get protonated, OH, right? Now see, here it is two hydrogens, right? So OH minus will take this hydrogen and minus charge will be generated on this carbon, right? So we will get like this, the double bond O, here OH and it is CH, right? Now minus charge will be generated here. Now what is happening? Even CB elimination reaction is happen, right? Minus charge will go on this bond and pi bond will be formed and this oxygen and carbon pi bond will be break, right? So here even CB mechanism will be followed, right? So we will get like this minus charge and there is a hydroxyl group and here CH3 is as it is and new pi bond double bond is formed here. Right. Now minus charge will be delocalized and pi bond will be reformed and this pi bond will shift here and OH will be removed. Right. So here is a dehydration step actually because here hydrogen and OH group will be removed as a H2O, so it's called dehydration also, right? So here we will get the product like this, right? Here it is CH3, right? So it is the alpha beta unsaturated carbonyl. So it is the aldol product and we will get the alpha beta unsaturated carbonyl compound, right? So let's take an example of this reaction. So we will understand properly. So we have a compound like this, right? Here it is a ketone. Now, if we react it with the base will take the alpha hydrogen and we will get the enolate intermediate, right? So it is O minus and here it is double bond. Now the second molecule of the reactant will come and enolate will attack on the carbonyl carbon and this bond will be opened, right? So we will get the molecule like this. Here it is double bond O and new carbon carbon bond will be formed. Second five membered ring is as it is. Here O minus one pi bond will be broken, right? So now this is a hydrogen and now with the H2O, oxyanion will be protonated, right? So oxyanion will be protonated and we will get the hydroxyl group on the carbon, right? And five membered ring will be as it is. Now, what is happening? Now, even CB reaction elimination reaction will be happen and H2O molecule will be removed from the this molecule, and we will get the double bond between two rings, right? Two 5-membered rings, we will get the double bond, and this will be our aldol product, right? So what we are doing actually, we are removing the H2O molecule from the two carbonyl carbon, two carbonyl compound, right? It is the aldol reaction. Now we will see the important topic, important concept, intramolecular aldol reaction. Intramolecular aldol. Here we have seen the intermolecular aldol reaction. There is a two aldehyde or two ketone molecules, and two different ketone or two different aldehyde molecules will be condensed and we will get the product. Now we have a single molecule, and the aldol reaction will be performed on the single molecule and we will get the product. And here the ring formation will be occur. Right. So let's take an example. Here it is the carbonyl carbon, and here it is the second carbonyl carbon. Right. Now what will be happen? We will react it with the base, and if we react with the base, this hydrogen will be taken, and there is the minus charge will be formed. So we will get like this, right? Here it is a minus charge, and this minus charge will attack on the uh, carbonyl carbon, second carbonyl carbon, and it will be open. Now, after reaction with H2O, the oxygen, here oxygen ion will be formed, which after the reaction with H2O will be protonated, right? So we will get the 5-membered ring. How? See, it is a first carbon, second, third, fourth, and fifth. Right. So first carbon, on the first carbon there is an ion, there is minus charge which are attacking on the fifth carbon. So here a single carbon-carbon bond will be formed between one and fifth carbon. So 5-membered ring will be generated. Right. So here carbonyl carbon is as it is, and 5-membered ring will be generated. Now we take a numbering 1, 2, 3, 4, 5. Right. So fifth, on the fifth carbon there is a single CH3 bond. So here it is a CH3 group and one hydroxyl group. Right. So here the pi bond will be break. Here oxygen ion will be generated, which is protonated after reaction with H2O. So here hydroxyl group will be generated. Now here the hydrogen, this hydrogen and the OH group will be removed as a H2O, right? As a water molecule via A1CB reaction, right? So we will get the product like this. Here it is double bond, and here it is a CH3 group, right? So it will be the final product. It will be the final product of the intramolecular aldol reaction, where we are generating a 5-membered ring, right? So due to the intramolecular aldol reaction, we are getting the ring, and the ring formation will be occur, right? So it was a aldol reaction, which is a very simple and a basic, also important reaction, because all the further name reaction we are going to take in the next video, right? Claisen name reaction, then benzyl benzylic acid, Cannizzaro novenzyl, all the name reaction will go to this mechanism. So if you understand this mechanism properly, then you can go for all this name reaction easily, right? So keep learning, keep practicing. We will see you in the next video. Till then, good luck. Thank you.